So this concept map we're going to use to take us through measuring matter and classifying matter. So we're going to start up here at the beginning with the center of all of this, which is chemistry. And we divide chemistry into two parts. So chemistry is the study of, part one is matter. Part two is how matter changes. So we are going to focus on the study of matter. Okay, so first we looked at how we measure matter. So matter is measured through lots of different ways, but we focused on four specific ways. We measured matter through mass, which we defined as the amount of matter. And we measured mass in units of grams. We can also measure matter through volume, which is the amount of space. And our most common units for volume are milliliters. Now, we said that we can do a ratio of mass to volume to get density. So if density is the ratio between mass and volume, that means the units for density are in grams per milliliter. Now, we can also measure matter through the number of particles. And the unit for that is moles. We can measure matter finally through its temperature, which we use temperature to measure the amount of energy. And units for temperature are Celsius, whereas the units for energy would be joules. So that's how we can measure all of our matter. Now let's look at how we can classify our matter. Okay, so our matter is held together by intermolecular forces. And I'm going to move this so that it's a little bit more centered. There we go. Okay, and our matter is held together by our intermolecular forces into our three states of matter. So we have solid, liquid, and gas. So our solids are going to have very strong intermolecular forces. Our liquids will have weaker intermolecular forces. And gases, we assume, have no intermolecular forces. So Since solids have strong intermolecular forces, that means those particles are going to be held closely together because those IMFs are the attractions between the particles. Okay, so that keeps them nice, neat, orderly, stacked together. Our liquid particles are going to be still close together, but they're going to be a little bit more random. They're not going to be neatly organized. Sometimes they'll get close together, but they'll be a little bit farther apart. That's because they have weaker attractions between them. And then our gases are going to be spread far apart because we assume that there are no intermolecular forces between them. Okay, so once we separate things into solid, liquid, gas, then we look at the types of particles in a particular substance. So if something has only one type of particle, we say that that is pure. And the smallest piece of a pure substance we call an atom. And for right now, an atom is just a solid particle. When we have lots of identical atoms together, we call them elements. Elements can come on their own, or they can come in pairs. As long as they're the same thing, even it doesn't matter how many are stuck together, it's still considered an element. Our elements are organized on our periodic table. We're going to talk more about that organization later. We can write about our elements because we don't always want to draw their pictures. So we can write about them using element symbols. And our element symbols are either going to have a capital letter, a single capital letter, such as boron or carbon, hydrogen, potassium, or it's going to have a capital letter and a lowercase letter, such as aluminum, chlorine, calcium, or neon. So those are our individual pieces. So what if we have more than one type of particle stuck together? Okay, so we're going to go back up here. So we've got two or more types of particles. If they're just in the same space, we call them a mixture. Okay, and we can have mixtures of our elements. So our mixtures of our elements might look like two different types of individual circles. So there's two different types of particles in that box, but each of those particles is just a single piece of substance. So it's just an atom or an element. Now, we can also have mixtures of things that are stuck together. Okay, so our particles that have two or more things stuck together, we call compounds. Okay, so compounds are going to have two or more different types of particles stuck together. Now, you can have, once you have different atoms stuck together, you make compounds. You can have pure compounds, okay? But that's when you have different atoms combined. You can have mixtures of compounds where you might have to different types of particles where you have things combined. So those would be two different types of particles, two different types of compounds, sorry. Two different types of compounds in one space would give you a mixture, be a mixture of two compounds. Now, we have a mixture of elements, we can have a mixture of compounds, also means we can have a mixture of elements and compounds. So that's where in one substance, in one space, you might have a compound and you might have some elements. Now, if we write about our elements using element symbols, we combine those element symbols to write about our compounds using chemical formulas. Now, our chemical formulas use our element symbols, such as hydrogen and oxygen, and it uses subscripts to tell us how many of each element are in a substance. So if we have 2 hydrogens and 1 oxygen atom, we would get H2O. So that 2 tells us that we have 2 hydrogens, and the O tells us that we have 1 oxygen. So when we combine our element symbols, so when we have element symbols, multiple symbols together, we can get our chemical formulas. And we use our chemical formulas to describe what we might see in a drawing for compounds. So that's a quick summary of how we can measure and classify matter.